Hello friends, today we are going to discuss disk scheduling, which is a basic mechanism in input output management for any operating system being used for any computer system. So let's start with disk scheduling. In this disk scheduling we are able to see introduction to disk scheduling, various scheduling algorithm, first come first serve, shortest seek time first, scan scheduling, sense scan scheduling, and log scheduling. Now, what is disk scheduling? As we know that for any user to use any resources for any system, it requests for some input, requests for some operation to be performed by applying input, and system provides output. So disk scheduling is the servicing the disk IO request, input output request. This disk scheduling is basically required for efficiently use for hardware. So to use hardware efficiently we required disk scheduling, which includes fast access time and large disk bandwidth. Now what is fast access time? It is a combination of seek time and rotational latency. In last video we already seen in input output management part 2, while we are using buffering with performance criteria for disk scheduling, we seen seek time, we seen rotational latency, and some of the rotational latency and seek time which provides the fast access time, which is a base for any disk scheduling to access hardware efficiently. Now inside a disk we already seen performance parameters for disk scheduling in last video. Actual head actuator is there, you can easily see head arm is there, and disk platter is given. Whatever disk having base on a particular chassis, what is the profile head actuator, you can easily see spindle is there, read write heads are there based on a particular disk platter. So what is actual disk scheduling, or how we are going to define disk scheduling? Input output request issues a system call to the OS. If desired disk drive or controller is available, request is served immediately. So whenever any request is issues as a system call to particular OS, if desired disk drive or controller is available, request is served immediately. If busy, new request for service will be placed in the queue of pending request. When one request is completed, the operating system has to choose which pending request to service next. So mechanism is clear. Whenever request comes, if disk drive or controller is available, request is served immediately. If disk controller or disk drives are busy, then new request for service will be placed in the queue of pending request. When one request is completed, the OS has to choose which pending request to service next. This is the overall scenario of disk scheduling. Now we are starting with FCFS scheduling, first come first scheduling. It is the simplest scheduling which perform operation in order requested. No reordering of work queue. So there is no starvation. Every request is serviced. It does not provide fastest service, as serviced are placed or what requested service are served within exact order. Example, a disk queue with request for input output, two blocks on cylinders are 23, 89, 132, 42 and 187. This is the order in which IO requests are made for service. with disk head initially at 100. So first 23 service will be served, then 89 service will be served, then 132 service will be served, then 42 service will be served, and at the end 187. So this is the basic scheduling algorithm, which is known as first come first serve, in which starvation cannot occur. If the request for cylinder 23 and 42 could be serviced together, total head movement could be decreased substantially. For example, 77 plus 66 plus 43 plus 90 plus 145. So how this head movement will be counted? As you can see, the initial head movement is at 100. Total cylinders are given 0 to 199, means total 200 cylinders are there. We are starting head movement from 100. First service is served to 23, so 100 minus 23, 77. As you can see, first is 77, then from 23 to 89, so 89 minus 23, 66, then 132 minus 89, 43, then 132, 42, 132 minus 42, 90, and at the end 187 minus 42, 145. So if the request for cylinder 23 and 42 could be serviced together, as you can see that from this chart, total head movement could be decreased substantially. Now we are starting with another scheduling algorithm, shortest seek time first scheduling. As the name suggests, whatever request require a shortest seek time from a current head, so whatever request is come for service from the head movement, we check which service required shortest seek time. So like SJF, in process scheduling, select the disk IO request that requires the least movement of the disk arm from its current position. Our current position is head arm, so regardless of any direction. Reduces total seek time to compare to the FCFS. As we already seen in process scheduling, when shortest job first, means whatever request comes, whatever process requires less time, which will be served first. Same thing for IO request, whatever movement from the disk arm required lesser time, that service will be served first, which reduce the total seek time compared to FCFS. Now what are the disadvantage of SSTF? Starvation is possible. Stay in one area of the disk if very busy. Switching direction shows thing down, not the most optimal. Now here is the example of SSTF. 23, 89, 132, 42, 187 are request. As you can see from same chart we already seen. Now SSTF first from 100, 89 will be 89 will be served first, then 132, then 187, then 142, then 23. Because from the available requests 89 and 132, but 89 is shortest towards the head movement, which is the 100. That's why 89 service will be served first, then 132, then 187, then 42, then 23. So head movement is obtained as 89, 100 minus 89, 11, 132 minus 89, 43, 187 minus 132, 55, 187 minus 42, 145, and 42 minus 23, 19. So total head movement will be 273. Scan scheduling algorithm: go from the outside to the inside servicing request, and then back from the outside to inside servicing request, sometimes called the elevator algorithm. So scan algorithm, we have to move towards one direction, starting from head movement, goes towards the either of the direction up to the end, again came back into the another direction, and and request or service the request whatever encountered during this end movement. So grow from the outside to the inside servicing request, and then back from the outside to the inside servicing request. That's why this algorithm is known as elevator algorithm. Reduces various variance compared to SSTF. If a request arrives in the queue just in front of the head or just behind, so as you can see that from 100 we are starting for 1 and 23, 89 and 42 south first, then again start with 0, 132 and 187. C scan algorithm. Now here we are using circular scan. Move inwards servicing request until it reaches the innermost cylinder, then jumps to the outside cylinder of the disk without servicing any requests. So circular scan moves inwards servicing request until it reaches the innermost cylinder, then jumps to the outside cylinder of the disk without servicing any request. Why C-scan is required? Few requests are in front of the head. Since these cylinders have recently been serviced, hence provides a more uniform wait time. So as you can see that here circular scan is provided rather than only moving on towards the just one direction. So head movement can be reduced if the request for cylinder 187 is serviced directly after request at 23 without going to disk 0. So in circular scan not every end point should be reached. Whatever service is there, it comes in direction it's out first, while in scan algorithm end point should be reached and after that end point come towards outwards. Now look scheduling like scan but stops moving inwards or outwards when no more requests in that direction exist. As you can see that 100, 89, 42, 23, 132 and 187. Neither of the directions endpoint can be reached, which is known as look scheduling algorithm. So now compared to scan, look saves going from 23 to 0 and then back. Most efficient for this sequence of request. Now from this all algorithm FCFS, SSTF, scan, C-scan and look algorithm, which one to choose? Now performance depends on number and type of requests. SSTF over FCFS. Scan, C-scan for system that place a heavy load on the disk as they are less likely to cause starvation. Now default algorithms are SSTF or look algorithm. Thank you.